In the third part of the video tutorial, related to diodes, we define the 4 rules for selecting the optimal diode to use in a power circuit, such as a rectifier. To choose the optimal diode, in the depicted rectifier, we calculate 1. The peak value of voltage in the circuit. 2. The average value of current. 3. The voltage, or current, period. The optimal power diode should have the following electrical characteristics. 1. Maximum repetitive peak reverse voltage, twice the peak voltage. 2. Maximum average forward current, 1.5 times the rectifier average current. 3. Reverse recovery time, 100 times smaller than the period. 4. Forward voltage, according to the table. An electronic component, specifically a diode, is destroyed due to overheating. Overheating is caused by a forward current greater than the maximum, or a reverse voltage greater than the breakdown value. According to its datasheet, the 1N4148 diode has a maximum repetitive reverse voltage of 100 volts and an average rectified forward current of 200 milliamps. We use the circuit shown to test the behavior of the 1N4148 diode at high currents. The average current is equal to 540 milliamps, which is significantly greater than the forward current of the diode. In the experimental setup, a multimeter equipped with a thermocouple is used to measure the temperature in the diode. An oscilloscope measures the voltage across the diode on channel 1 and indirectly the current on channel 2. Power consumption is excessive. As a result, the diode overheats and eventually breaks down. The diode can arbitrarily open or short circuit during overheating. In the cases shown, both diodes are short-circuited. In some cases, the diode can work normally after overheating. The behavior of the 1N4148 diode at high reverse voltage is tested by the circuit shown. Using the 1N4004 diode and a variac, only a reverse variable voltage is applied to the diode. The diode operates normally as long as the peak value of the voltage is lower than the breakdown value, which is 150 volts. Once the voltage exceeds the breakdown value, the diode begins to conduct current, according to the formula. At the same time, the high breakdown voltage is imposed on the diode. Power consumption is excessive, and the diode in a few milliseconds collapses. Allow the diode to cool and apply voltage again. The diode collapses at a much lower voltage, about 50 volts. Although the diode is damaged, it looks fine when tested with the multimeter in diode mode.